day of next week. So, what we've got to do today is simply finish up on Chapter 12, and we're almost there. So, yay! It's beautiful, it's sunshiny, it's warm outside. Hopefully we'll be out here by 3:15. Okay, any questions before we get started? Okay, so we left off at the point in Chapter 12 where we had made it to the area of the chemical synapse. One of the things I'm going to remind you about is at that area of the chemical synapse, remember that end of the neuron is meeting either a muscle, a gland, or another neuron. And the chemicals now, the chemicals are going to be different because we're now looking at the product that the neuron makes. And remember, a neuron is a cell. It's the only thing that the cells can produce is a protein. But this time, we're releasing the product, and it's termed a neurotransmitter. If you think about that term, and if you look at our structure that we have in the synapse, we're dealing with a neuron, neuro, the chemicals, those proteins that it can make, and their job. And the one thing about the neuron, they transmit an action potential. Therefore, a neurotransmitter. When we look at the neurotransmitters, well, let me ask you guys a question. Have you ever heard of a neurotransmitter? What kind, Yvonne? Okay, our acetylcholine. Do you have another? Those are going to actually be hormones. Now, the kicker of that, okay, because we're going to find that those two systems that run the body are going to be the endocrine system, which produces the hormones, and our nervous system with the neurotransmitters. Some of those hormones can fall into being a neurotransmitter. So you're probably thinking about some of those that are falling into a neurotransmitter. Any others? Serotonin. Why have we heard about that?
Depression.
Okay, we hear about it with depression, sleep, usually like on the medication commercials and that sort of thing. There are tons of neurotransmitters, okay? And we classify them, we put them into different categories. We're going to say, first of all, we got acetylcholine. That one, straight up, for the muscular system. Now, does that mean that it's not going to play a part in other areas? Yes. But the only neurotransmitter that a muscle cell can use is acetylcholine. It can't use anything else. We're going to find that we have amino acid neurotransmitters. What is that? What's an amino acid? What do they make? Protein. Okay? They are what strings together to make protein. But now, when we talk about them being a neurotransmitter, for an amino acid, it's going to be looking at the putting together of those amino acids, the 20 that we have. We've got some that will work as just the amino acids themselves. For example, Glycine. Glycine is one of the 20. Glutamate, one of the 20. Do you see where I'm going with this? Now GABA, got that up there in great big huge letters. Ever heard of that one? You take gabapentin. Why? Do you know what it does? What it helps with? Ever heard of gabapentin? Okay, do you know what it helps with? Okay, this is a medication that you hear people taking who might have, for example, some type of neuropathy. Ever heard of neuropathy? Okay, what is it? They got tingling occurring somewhere within their body. And it's like no matter what, they can't make it stop. People, for example, can have it in their feet, and it's very painful. Gabapentin is a medication. Do you remember how I talked about some when we have a transmission along a neuron, it's just as important to stop the transmission as it is to continue it, okay? Gabapentin is thought to stop that transmission. And it's thought to be like a connection between those nerve endings and the nervous system for the transmission of those signals. It's thought to be inhibitory, to put it in excitatory or inhibitory. Monoamines. Now, monoamines, they're going to come from amino acids. Well, a lot, the majority of what we're going to have as neurotransmitters, they're going to be amino acid based. So, monoamines, have you possibly maybe heard of this one also? Maybe you've heard of an MAO inhibitor. No? Okay, good example. Monoamines, they're believed to play a part in depression and anxiety and stuff like that. Okay, but let's say that you know someone that no matter what the activity might be, alright, they'll ski down the highest mountain. They'll jump off the building, face jump. They might get on that ride that, you know, on the little, you're in like the little thing and you get taking up like 500 feet up in the air. And then all of a sudden they let it go and you're like, woohoo! Okay? No, not me. Okay? These are people who tend to have no MAO inhibitors. So that means there's nothing in their body blocking their release. And so these people are adrenaline junkies because they're basically pumped up all the time. Alright? And I got lots of those inhibitors. Okay? Because about the wildest thing I'm going to ride is the hockey horse. So, you'll sometimes hear about that. Now, neuropeptides. Not sure if you remember, but we talked about those when we discussed Chapter 26 with the digestive system and how we had these peptides, these gut-brain peptides that made the connection between the nervous system to help us determine if we were hungry, satisfied, that sort of thing. Okay? So we put them into those categories. Now, when we talk about the neurotransmitters, one of the things about this, when we look in these is going to meet, whether it's a muscle, a gland, or another nerve cell. We're going to find that what it meets has receptors. For example, muscle fiber, which I had drawn earlier, okay? Do you guys remember how the muscle fiber had that neuromuscular junction? That was the area where it met. What? The receptors at that area are only going to be for acetylcholine. Would I have receptors on that muscle fiber for dopamine or serotonin? No. Okay? So, what it is meeting is going to determine the types of receptors that are found. Now, that's cardiac muscle. That's skeletal muscle. So, receptors are going to be different based on the cells that they are. Okay? So, a skeletal muscle is important. Okay? Now, other cells, okay? Other types of muscle cells. We've got smooth muscle, okay? We've got cardiac muscle, both of which are affected by something such as epinephrine, okay? It's affected by, what's the one that makes you hold the belly fat? The one that I have a whole bunch of. It's going to come to me as I'm talking, okay? And I'll have to go.
It starts with a T, right?
Starts with a T. Cortisol. Okay, got a whole bunch of them. Now, each cell of the body is going to have receptors. All right? Now, not every cell in the entire body has a receptor for every neurotransmitter. That's not going to happen. Okay? Now, like I said, neurotransmitters, either excitatory or inhibitory. If it's excitatory, for the most part, it's going to get a response. If it's inhibitory, for the most part, it stops something. Okay? Trust me, there are exceptions. But for the most part, that's how we're going to think about it. Some of these neurotransmitters, for example, norepinephrine. Ever heard of it?
Yes.
Why?
It's one of the cardiac drugs you can give, like the AMS, or if
Is the norepi or is it epi?
Both.
They use both?
Yes.
What do they use norepi for?
If the heart rate's too high, we can try to bring it down that way.
And so if it's too low, they'll give epi?
Mm-hmm.
I didn't know they did a norepi. Does norepi precursor to epi? That's kind of interesting to me. I have to think about that. See, I don't want to think again. I don't want to think anymore, y'all. Okay? I don't want to think anymore. Okay? So, here's something that happens. When we have our synapse, we're always going to have the synaptic neuron will always have the area of the synapse